Continuing on with 16 through 20, speed run. Number 16 says, for the function f of x equals absolute value of 2x minus 6x, what value of c works for f of 3 minus the f of c equals negative 24? I would first start by simplifying the expression here to just the absolute value of negative 4x. And let's think about what are they looking for here. This is actually f of 3 would be negative 4 times 3 minus f of c equals negative 24. And this is going to be negative 12. The absolute value of negative 12 is just 12. So they're really saying 12 minus what would be negative 24. You do little calculations, and we know that this needs to say 36. Okay, 12 minus 36 is negative 24. So what they're really saying is f of c, okay, needs to be 36. Well, since it is actually negative 4 times something, okay, what do I times 4 by to get 36? It would have to be 9, right? The absolute value is positive 36. B would be our correct answer. Moving on to 17. It reads, when considering the exponential function f of x equals g of h to the power of x, which of the following equations in the same form does g show the value of f of 0? It's a mouthful there. Really, they're really paying attention to g, and they're saying when you plug in 0 for x, which of these has a g that will not change? That's what they're asking for there. So A, B, C, or D, when you plug in 0 for x, we're looking for one of those values to not change. Well, I notice here that when you raise anything to the power of 0, it really just becomes 1. Any number to the power of 0 is 1. So 1.25 to the power of 0 is 1, and that is going to give us an output of 15. Answer is B. Looking at 18, the number of views on a popular YouTube video a week after it was posted is represented by the function f of d equals 5,000 times 3 to the power of d over 15, where d is the number of days that have gone by. How many days will it take for the number of views to triple? Well, they're starting out here with 5,000, and the 3, if we just times it by 3, it's going to triple. So really they're saying at what value would this be to the power of 1? If we zoom in here, 15 over 15 would be 1. So it's that simple. B is your correct answer. Moving on. 19, we have a equation there, 3 fractions. It says the variables b, c, and d above are all positive integers and d is greater than c. Which expression would be the result of solving for b? So we want to isolate b. If c or d, think about it, if c or d were negative, then these would switch to positive. So that's why that little information about them being positive is being included. So I've rewritten the equation. I'm going to isolate b, so I have moved the negative 2 over c to the other side, making it positive. So let's keep working here. First, I notice all the answer choices are using the number 4, and I have an 8 and 2 2s. And so I think it would be wise to first divide this by 2 so that it looks similar to their answers. So we actually have 4 over b equals 1 over c minus 1 over d. Starting to look better. None of their answers have the fractions separated, so we actually want to combine that right side. We're going to use our rules of fractions, multiply both of those by d and both of these by c, so that we can combine the denominators there. And we're going to end up with d minus c in the numerator and a simple cd in the denominator. Okay. I don't want to multiply both sides by b here because that's going to create extra work. And so I'd like b to be in the numerator. And since these are two fractions um, equal to each other, we can actually flip. We're going to flip both of those over to their reciprocals. Okay, now this is starting to look a lot more manageable. My last step here to get b by itself is to multiply by 4. That goes over here in the numerator, and we have answer here, which matches C. Moving on to 20. We got a graph here with temperature and time passed in hours. It says beginning at midnight, Julia recorded the outside temperature every hour for 8 hours. What was the average rate of change from 2 a.m. to 6 a.m. in degrees Celsius per hour? This is 2 a.m. here. This is 6 a.m. there. And we'll notice that at 2 a.m., it was -3 degrees Celsius. And at 6 a.m., it was -9. So in 4 hours, okay, in 4 hours, and we actually want to put the y in the numerator there, it went down 6 degrees, -6 degrees Celsius. And we want to simplify this rate of change into, this would simplify to -1.5 degrees Celsius per hour. There you have it.